Hey everyone, Miss Dasso here. Hope you're all doing well. Just wanted to let you know I miss you. I miss joking around in class with you guys, giving you guys a hard time about stuff, hearing about your days. So I hope you're all doing well. Hope you're finding a way to be a little bit active, whether that be inside or outside, going for a walk, just to keep your minds clear and having fun. So today we're going to talk about our circles, our circle introduction. Some of the vocabulary you may be familiar with, other of it might be kind of new, but the vocabulary is important here. So for our do now today, we're going to label the circle using the terms radius, diameter, and circumference. So first one we might start with is our radius, that little guy right there going from the center point to the edge of our circle. That's a radius. Then we have our diameter, which spans the whole width of the circle and goes through the center point as well. And that is our diameter. Okay. Then last but not least is our circumference, which is all around the outside of our circle, the edge. I like to think of it the same way we think of a perimeter of a triangle or of a rectangle, but circles are special, so special name, circumference. And then we just want to notice the relationship between the radius and the diameter. If you visualize in your mind, if we were to slide this radius along the edge down, we notice that would be half as long as the diameter. So if the diameter of a circle is 8 centimeters, what is the radius? Well, it's going to be half of that. And half of 8 is 4 centimeters. Okay, so obviously we divided by 2 or multiplied by 1/2. That one was kind of quick and easy. Okay, so let's take a look at a few more circles. Again, here I've got this nice picture of a circle. All my hand-drawn circles today are brought to you by my stencil, which was an empty container of Clorox wipes. Only seems appropriate given everything going on. So here we've got a line from the center point out to the edge, which we call a radius. There are infinitely many radius in the circle. It can be drawn from the center point out anywhere. When we have multiple radius, we call them radii. Again, a line through the center of our circle spanning the whole width is our diameter. Okay. Just like our radius, there are infinitely many diameters in the circle, just going anywhere through the center point, connecting to two edges of the circle. Okay. And the distance around our circle is what we called our circumference. Okay. Good. All right, so let's do a little practice. So this circle here, we're given some information. We're told that the radius is 12 meters. So 12 meters here. If the radius is 12 meters, how long is the diameter? Oh, look at you, so smart. Yes, the diameter would be 24 meters, okay? And we want to just kind of formally write down our relationship that the diameter is equal to 2 times the radius. And that's how we're going to label that. Lowercase letters for our diameter and our radius, D and R. Okay. In our next circle, this time we're given the diameter, that the diameter of our circle is 62 feet. We want to know what is the radius. So we should be remembering that our radius is half the diameter. So then our radius would be, yep, that's right, 31 feet. Okay. And just to write that down a little formally, we can write that the radius is half the diameter, or we could write it as a division problem. Also, radius is equal to the diameter divided by 2. And these two facts, that the diameter is twice the radius is 1/2 the diameter, is a fact in math we want on quick recall. So some of you might be asking now, okay, diameter, radius, well, where does circumference come into play? And that's really, really cool. This is where math gets really interesting. Okay, so the circumference and the diameter of a circle have a very special relationship. And that was discovered or formalized way back when in math, in sort of our ancient Greece. We've been talking about Euclid a little bit. So what mathematicians did was they looked at circles, measured around the outside using a rope or sort of a flexible measurement, and then measured across the center with the diameter. And they did that for a bunch of different circles they noticed in real life, wheels, different things like that. And when they wrote it as a ratio of circumference to diameter, they noticed something. They noticed that they always got something somewhere around 3. Not exactly 3, but kind of close to it, over and over and over again. And they noticed that as being something really special in math, and they gave it a special letter in the Greek alphabet, which is the letter pi. Okay? And we know pi is that poster child of our irrational number that goes on forever and ever and ever and never stops and never repeats. We should know that pi is that relationship of circumference to diameter as a ratio, and that its number approximation is about 3.14 and continues on. There's infinitely many digits. I only have memorized 3.14159, and it goes on. I don't really see a point in memorizing it because we have a pi button in our calculator, and that's way more specific than I can be memorizing. Okay, so we talked about circumference, our distance around the outside of our circle. How does this work for us finding circumference? So if we think of our relationship now, where we're talking about pi being the relationship, and I'm going to abbreviate, circumference over diameter, how do we find circumference? Well, I want to know circumference. Let me solve for C algebraically. So I've got to undo that division. Let me multiply both sides by diameter to isolate the C. Multiply here, and then we get D times pi equals C. And that's where our circumference formula comes from. Circumference is equal to pi times the diameter. We know that diameter is 2 times the radius, so we could also say that the circumference is equal to 2 pi r. And either one of those can be used for our circumference. Okay? Now let's talk just for a moment about area. So something we should remember, area is the area inside of a figure. Here I have a rectangle, a parallelogram, a quadrilateral, whatever you want to discuss it as. And we should remember from our earlier studies of geometry that to find the area of a rectangle, a parallelogram, we're going to do area is equal to the base times the height. Okay? So we've got our base down here, our height over here. Okay, and that works really nice for our parallelograms. And mathematicians knew that. But unfortunately, that doesn't work too well for a circle. So what mathematicians did is they take the circle and they carve it into these little sectors here. These tiny, tiny sectors, and they try to get it as small as physically possible. If you notice, every one of these blue lines is a radius because it's extending from the center point out to the edge of the circle. So the piece I pulled out over here, we've got a radius here, a radius here. And then the outer edge of our circle is our circumference. Okay, so even this little piece is just a tiny piece of our circumference. So what mathematicians do is they cut up this piece into all these sectors and then they rearrange it. And when they rearrange this circle and they slide their pieces together, they get something that looks a lot like a parallelogram. So they're like, oh, okay, well, maybe I can use our parallelogram formula where we have our base times our height. Okay, and I'll start with the height. We can see our height over here. And if you notice, the height here is that blue line. That blue line we had above, that was actually our radius. So instead of thinking of our area formula with height, we can just instead say radius. And then we have the base. I have that purple line here and purple line here, which shows us our circumference. So this bottom purple line, our base, is really half of our circumference, or I'm going to say 1/2 C. So that'll be 1/2, and remember, we know our circumference is pi times diameter. Okay, so I'm going to substitute in for C. Circumference 1/2 pi times diameter. And wait, what's half the diameter again? Oh, that's right. It's the radius. So really, that's pi times the radius. Okay, so our base is really pi r. So if we follow through with that and substitute in, our area of our circle is going to be pi r times r. Well, r times r is just r squared. And there is our area formula of a circle. Okay? So 2 important formulas today we went over. Circumference equals pi times diameter, and area equals pi r squared. Now here's a fun way to remember it. I didn't learn this till I was in calculus in high school for my teacher, Mr. Meltz, and I thought it was really great, so I'm going to teach it to you now. So circumference equals pi times diameter. We can remember that as cherry pie delicious. And then area equals pi r squared. Apple pie r2. Cherry pie delicious, apple pie r2.